We are now going to look at graphing tangent. Alright, so we got the equation y equals tangent of 2x. So let's go ahead, let's pull out our information as always. So there's no number in front, so we assume it's a 1. And that amplitude is going to be 1. There is not a reflection. Remember, reflection is if there's a negative number inside here, or on the outside. No negative here, so no reflection there. Also, there is no number being added on the outside, so there is no vertical shift. The only thing that has a number is that 2 inside. That is going to give us a period change. Alright, so my period, remember, tangent and cotangent are slightly different. Instead of doing 2 pi over w, it's always just really the original function's period. So tangent has a period of pi, so it's going to be pi over w. So here it's going to be pi over 2, which is just, hey, pi over 2. Step, same process. My new period divided by 4. So pi over 2 all over 4. I'm going to turn both these into fractions. So this is 1 over 4. Comes pi over 8. So there's this, and now I'm going to go ahead and make some, I'm going to set up my my step here. So I'm at 0. I'm just going to give myself, well, here's pi over 8. I'm not going to mark each one. Pi over 8, this would become pi over 4, and that would become pi over 2. Just want to give myself a little bit of space. And I'm going to keep going this way. So then this would be the next one. So then this would be 3 pi over 4. And then it's going to be pi. I have no amplitude change. Or sorry, no midline change. So my midline is still going to be at 0. Amplitude is going to go up to 1. 1 and negative 1. And now I'm going to go ahead and graph this function. So tangent's the only one that's a little funky. Once you get your first point, you're good from there. So you got to ask yourself, this original point at when x is 0, alright, tan of 0, right, is that undefined or is it at the midline? Well, if you don't remember, tangent is going to be sine of 0 over cosine of 0. Or another way to think about it is, hey, it's y over x with our quadrantals. And so boom, here's my quadrantal. This is the point 0, comma 1. So y is 1. Sorry, this is point 1, comma 0. So 0 over 1, which is 0. So tangent's going to start on the midline, actually. Right. And then that means we're going to skip 1. And so my quadrantals are here. We skip 1 and it's the next one, skip 1, next one, skip 1, next one, and so forth. So, oh, did I? I messed up my scale a little bit here. Oh, no, I didn't. There should just be a tick mark there because my step is pi over 8. So we're good. So I'm going to skip 1 and then, hey, boom, vertical asymptote. Then when I skip 1, I just had my vertical asymptote, so now I'm going to have my dot. I'm going to skip 1 and have my vertical asymptote. And then skip 1 and have my dot. And then tangent is going to go up, kind of to the top. We're just going to go, it just hits our amplitude is the next gap. So amplitude, and then our negative 1, and then our positive 1, and then our negative 1. And this is what tangent is going to look like. We're going to have up. This one's going to kind of be a little S look. And then, again, if I kept going, this one come up, and then I'd have another vertical asymptote, and then I keep going. But this is just 2 periods worth of tangent. Right? And so I know tangent's a little funky, but once you get the starting point, you can just, hey, it goes starting point to the max or to the, not the max or the min, but the top or the bottom. Then it's an asymptote. And then just repeat itself. Bottom, middle, top, asymptote. Bottom, middle, top, asymptote. And you keep doing that pattern. So here we pick it up as middle, top, asymptote, bottom, middle, top, asymptote, bottom, middle, top, asymptote, as we keep going on. Right? And that's how you graph tangent.